Now let us know about polarization. To understand what is polarization, let us consider transverse waves, mechanical transverse waves. Here this is the cardboard in which a slit is made vertically, and this is the thread passing through this slit. Let us assume the thread is made up of large number of molecules. If one of the molecules is disturbed like this, the disturbance propagates. This is nothing but wave. So this wave passes through this slit. So here the wave is propagated from left to right along this line, but the particles are vibrating up and down, means perpendicular to this line. This type of wave is called transverse wave. Look at transverse wave can pass through this vertical plane because the direction of the plane is parallel to the direction of vibration of these particles. Now let us see what happens when this slit is rotated. Look here, the slit is made horizontal. Now let us produce same transverse waves like this, and these waves propagate up to this point, and here this wave is cut. It cannot pass through this horizontal slit because the direction of this slit is perpendicular to the direction of vibration. So this cutting, this stopping of wave here is known as polarization. So now let us discuss what happens when we produce longitudinal waves. Look here, this is once again a vertical slit, and here by disturbing this particle like this, we produce longitudinal waves. These are longitudinal waves because waves are propagating in this direction. Parallel to this direction, these particles are vibrating. Therefore, they are longitudinal waves. Look here, the longitudinal waves pass through this vertical slit. Now let us see what happens when this slit is rotated horizontal. Now the slit is made horizontal like this. Now let us produce longitudinal waves, and look here, even through this horizontal slit, these longitudinal waves are passing. It means longitudinal waves cannot be stopped by this slit. It means the longitudinal waves cannot undergo polarization. So only transverse waves can undergo polarization. So this is about how mechanical waves undergo polarization. Now let us discuss polarization of transverse waves. Of course, from these two experiments, it is cleared that only transverse waves can be polarized. Light is electromagnetic wave. Look here, this is the source of light, for example torch. It produces electromagnetic wave. Look here, these lines represent electrical vectors, and these green lines represent magnetic vectors. Look here, variation of this electric field like this with respect to time and with respect to position also. Look here, this is variation of magnetic field. This magnetic field and electric field vibrate perpendicular to each other. Look here, if electric field vibrate parallel to the screen, magnetic field vibrate perpendicular to the screen. So they are mutually perpendicular, and they travel perpendicular to both of them. Look here, in this direction. So this is electromagnetic wave and how it propagates. Now look here, let us place this slit somewhere here and observe this electric field vector. So this is the electric field vector. During the propagation, look here, the length of the field vector decreases, it increases, and again decreases and increases in the opposite direction. The increase and decrease of this line or vector is nothing but varying the magnetic field or electric field at this point. So this variation in the electric field strength at a given point is nothing but fluctuation of electric field. So like this, electromagnetic wave consists of fluctuating electric field and fluctuating magnetic field in mutually perpendicular directions. Of course, even though light consists of magnetic field and electric field, it is enough to consider electric field only, because this electric field is responsible for our vision. It means the electric field in the light is responsible for vision. Now let us see how electric field is vibrated. Consider a charged particle like electron. When this electron is vibrated like this, it produces electric field, and that electric field vector is represented by this line. This is vibrating. Look here, in the plane of vibration electric field is produced. But in a substance, if you take a small piece of substance, it consists of millions of electrons, and when these electrons gain energy, they vibrate in different directions. Suppose this electron vibrate in this direction, it produces electric field in this plane or in this direction. The another electron vibrates in this direction and it produces electric field in this direction. Like this, electric field is produced in all the directions. Suppose if the light is emerging from this screen perpendicular to this light in all directions, electric field will be there. This is how electric field vectors around the light. If you imagine light is emerging from this screen and perpendicular to the plane of the screen, so perpendicular to the direction, that is the light coming towards us, perpendicular to this direction, electric field vectors are present in all the directions. Look here, like this. We know electric field is a vector quantity, it can be added vectorically. And now let us imagine components of all these vectors in mutually two perpendicular directions, and they will be added like this. As these vectors are added, so we get two components, resultant components. Look here, this is called horizontal component and this is called vertical component. So like this we can assume the light as horizontal and vertical component. So this type of light is called unpolarized light. Actually in a light, electric field vectors are present in all directions. Such light is called unpolarized light. We assume them to be added vectorically and consists of two mutually perpendicular components like this. If this is rotated like this, we can see tip of this vector and this is represented by a dot. Dot means a component perpendicular to this screen, and this is the parallel. Here the light is propagating in the plane of the screen like this, parallel component and perpendicular component. So this is unpolarized light. Once again, look here, electric field vectors are present in all directions perpendicular to the propagation of light. This type of light is called unpolarized light. So they can be added into two components. One is vertical component, this is the horizontal component, and here vertical component is represented by a line like this. This is parallel to the plane and this is perpendicular to the plane, perpendicular component and parallel component. Now let us know about Polaroid. Look here, the thin sheet like a plastic is a Polaroid. It consists of long chain of molecules. Look here, this is one chain, this is the another chain like this. They are aligned in a particular direction. If light incident on such a sheet, the electric vectors parallel to these lines absorbed by this Polaroid, and electric field lines, electric field vibrations perpendicular to this will be passed through this one. Therefore we can consider lines or axis perpendicular to these long chain molecules. These lines or these axes are called pass axis. Means through them electric field vectors in a light can pass through. The axis perpendicular to the long chain of molecules, this axis is called pass axis. It is like this. Look here, this is the Polaroid and these are pass axis. This is the source emitting unpolarized light. Means light is, vibrations are present in all directions perpendicular to the direction of propagation. Look here, through this Polaroid only vibrations parallel to these pass axis are coming out, and all other are absorbed by this Polaroid. And now this phenomenon is known as polarization. Look here, this is unpolarized light and this is plane polarized light. When unpolarized light is passed through Polaroids, the vibrations parallel to the path axis only can pass through the Polaroid. This phenomenon is known as polarization. Look here, this is unpolarized light and this is plane polarized light. Look here, in this plane light is polarized, and look here, these are path axis. Parallel to this path axis, the vibrations are emerging out from the Polaroid. Look here, this Polaroid is rotated through certain angle, and now look here, these are the path axis. Parallel to this path axis, vibrations are passing through this one. All other vibrations are absorbed by this Polaroid. So this is also plane polarized light and this is unpolarized light. Look here, this is unpolarized light and this is the path axis. Parallel to this path axis, the vibrations are emitted from this Polaroid. Look here, representation of unpolarized light. Here all the vibrations are added, vectorically added, and we get two components, one parallel component parallel to the plane and another perpendicular component. So this is how we can represent unpolarized light. If we take only this thing, that is only parallel component, this is the plane polarized light, and if we take the dot, it represents vibration perpendicular to the plane, it is also plane polarized light. So now consider this one. If light is represented only by dots, it means vibrations are present only in a plane perpendicular to this screen, and this is plane polarized light. Suppose if the light is represented by only parallel lines or parallel components, here vibrations are present only in the plane parallel to this screen. This is also representation of plane polarized light.